Hello everyone, this is Universum, the place where you learn about the entire universe, how it began and how it will end. Today, we are going to be talking about U-Substitution and how to apply them to integrals. Now just to get a little bit of review on, for those who don't know what a integral is. Integral, basically, it'd be finding a range. So there are two different types of integrals. There are indefinite integrals and there are definite integrals. Indefinite integrals, what they do is that, they have absolutely no limits to them, and they usually just are for finding standard derivatives. And then definite integrals, they have an upper and a lower limit. And sometimes the other integrals, they usually are trying to find the area under an infinite length, while definite integrals, they usually are like finding the area under a different object, say for instance like a circle. But if you're trying to find out closed systems, since definite integrals, what they can be used for is that, let's say we have two lines. There's two lines next to one another, and then let's say if you have the integral of 0 to 2, and then x squared. I know this is going to be quite easy, but, hey, this is just as some review. So now, first, what you have to do is that you would have to find the derivative of that integral, one of the integrals. And by finding one of the derivatives of one of the variables, what you can do is that you can incorporate that into your answer. Now, remember, don't get this confused with the integral of x squared. So that one's a lot easier. When really, when you calculate it, you'll get a much, much different answer than what you're supposed to get. So let's say if you were to calculate it, what you would get is that you would get x to the third over 3 plus c. Why do we have that? Well, you would need to simplify this down to an indefinite integral. Because right here, this is a definite integral, not an indefinite integral. So then now what you do is that you simply just simplify it down to 2x, but then you unsimplify and then you add the constants together. And then you take away whatever is left, and then you make them into a fraction form, and then you keep the constants. And then by using power rule, you can bring any constants to the front, multiply by anything else, and then that's how you get x to the third over 3 plus c, because c always appears whenever you are having any type of integrals that are indefinite and have no limits to them. So now let's do a little bit of a different. Now a little bit of the basics of an integral. Now let's do a different one. So say, for instance, now let's go into like a little more trigonometry. Like just getting a little bit more complex. So as it gets a little more complicated, what you'll get is that. So let's do the trigonometric one. So the trigonometric one is going to be the integral of sine of x. Of course, this is going to be negative cosine of x. Easy as pie. Of course, you can do plus c as well. Then, of course, if you're doing a continuous function, what you can do is you find the limit of it. Many, 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 many different ways of doing it. So now let's do a different integral. This one is going to be a U-substitution integral. So now, let's say if we were to do this integral, the integral of x squared, and then that's going to be evaluated by the product of x cubed minus 7 cubed dx. So now what you could do is that you could substitute. The reason why this is called U-substitution is that you can substitute any constant binomial factors with u. So then we just do that x cubed minus 7, you can simply substitute that with u. And then what we can do is that you can evaluate its derivative of that equation by du. So you can make its derivative du, add back to the equation. You can cancel out the x of the equation due to it not being a constant. And then you can replace it with 1 over 3 due to the derivative of x cubed minus 7 cubed. That simply is going to be, well, of course, combined with x squared, of course. That is going to be 1 over 3 x cubed, so squared. And then you simplify that down into 1 over 3 u cubed. And then what you do is that you can factor out then what you can do is that you can factor out the other one. You can factor out the u. We'll factor out the 1/3, of course. Yeah, sorry, I'm getting a little rusty. So then as soon as you factor out the 1 over 3, what you can do next is try to get the back into the equation and then do the substitution of du over dx. And then you can get the dx again, and then you can finally get back your x's, and then that would be your answer. Now, if you want a little bit more of an explained one, now let's do a little bit of a better one. So let's say if we have to evaluate the integral of the integral, sorry, not the integral, the integral of x squared plus 5 multiplied by 2x dx. So what you can do is that you can make them into a function of x first, but that's not going to really work so well in order to make it a little bit faster. So what you can do is that you can let u equal to x squared plus 5, because that is going to be one of the brackets that's going to simplify it down a little bit more. All right, so now we have the integral of u to x dx, which is a lot simpler. Another way you can do this, if you like doing a little bit more limits, what you can do is that you can do a store function if you want. But that's just for added complexity for those of you who like doing that. So now what we do is that we have to separate the two variables of u and x. And in order to do this, we need to take a derivative of u, which is, of course, as we know before, du. So what we do now is that u, of course, as we know, is going to be equal to x squared plus 5. And then du is going to be equal to 2x dx. Yes, that's right. The dx does get included in the U-substitution, but that's only for some cases. So be very, very careful when you do that. Then what happens is then you try to find the derivative. Then we do is then you substitute the dx out. And then what you do is that having a dx in a factor function kind of screws everything up and makes it extremely hard to do. It's like having the integral of dx over x squared plus 5. That one's going to be quite hard to do due to the dx is not going to be in the place where you want it to be. So yeah, if I were you, I would recommend substituting the dx with du. That makes it a lot easier to do. So then in the end, you'll find the derivative of 2x, which is just simply 1 over 2x. Well, of course, the derivative of 2x dx, of course. And then because the derivative of x is just 1, you factor that, put it over 2x, and then call it a day. Well, of course, but we're nowhere near done yet. Then what we do next, and then we can plug in the substitution for dx. And then we get a more simplified integral of the integral of u to x dx. Of course, we heard that before. And then we substitute that for dx. And then we do the integral of u of 2x multiplied by 1 over 2x. Yes, we include the derivatives at the end. We don't put them towards the front unless they are constants. Now, of course, because these constants are in brackets, well, they sort of are trapped within their own products, so they don't really matter. Then what we do is that now the 2x can be canceled out because, well, since there are two 2x's, and, well, kind of gets interesting. So then what you do is that then you cancel the two 2x's. So the 2x that is in the first bracket, you first cancel that out. And the 1 over 2x, well, since 1's also a constant, same as 2x. 2x, well, that all that entire thing is a constant, so you both just cancel that out. And then you simply just get a really simple integral, which is going to be the integral of u of du. And then, of course, you might run into a little bit of a problem, which is going to be a little bit interesting, is that, well, you're going to need to put it back into x terms a little bit. Because if you've had x terms this entire time, go back and redo it. I know, it's a little sad, but yeah, you're going to need to go back and redo it. So what you're going to need to do is that now we can integrate the integral of du, of u du. And then we can do with that, just because it's an indefinite integral, as we learned from before, u is going to be equal to u squared over 2 plus c. You need the plus c. Don't forget it. And then there is one more step with the U-substitution, because that u is just, well, that's just a substitute variable, of course. So now we're going to need to plug in the original function, which, if you remember from before, is just x squared plus 5. And then what we're going to need to do is that, so then now we're going to need to plug it in. Now it's going to be the brackets of, or the product, if you will, the product rule of x squared plus 5 squared over 2 plus c. And then you substitute the u out, and well, that is your final answer. I know, U-substitution does take a little bit of time to do, but, well, hey, you know. So I hope you guys enjoyed this short little video, and I'll see you guys next time. I hope I helped you out in calculus, and I'll see ya.